Hi, this is my video number 22. Alright, I'll talk on the scope and lifetime of variable in a function. Okay, so basically what happened in this video, I just read from your notes and I explain where necessary. So the scope and lifetime of the variable that we normally define in C, so it's depend on how do we define the variable. Yeah, basically we have 4 categories, yeah, of the variables. So we call as automatic variable, external variable, static variable, and register variable. So automatic variable, that's what we normally use in your programming thus far, or also known as a local variable. External variable or global variable in C, we I think at least in our case we haven't used yet, but can be used, and as well as static and register variable. So scope and lifetime of the variable depend very much on how do we declare, either it's local, global, or static or register variable. Okay, so first we go to the automatic variable. So what is automatic variable? As I said earlier, the automatic variable, also known as a local variable, this is what we widely use in the programming. So they are declared inside a particular function and created when the function is called, and destroyed when the function exists. The automatic variable are local or private to a function, in which they are defined by default, or the variable declared without any storage specification is automatic. So the values of variable remain unchanged to the change that may happen in other function in the same program, and by doing this no error occurs. So what does this mean? So look at this example. We have the example here. I hope you can see this a bit small, yeah. So look at this example. So this is just a normal part that we need when we do programming, include main as a main function here. And then in the next page, if you look at the next page, yeah, so we have here m equal to 1000. We define in the main m equal to 1000 of type integer. Then we have void 1, void 2, local. So which means we tell the compiler that in this program we have two functions called function 1 and function 2, apart from main, of course. Then we call function 2. Okay, we call function 2. Now, as soon as the compiler meets this calling function, we call that function 2. So it goes direct without looking at the further. It goes direct to the function 2. So where is function 2? Function 2 is, yeah, this is function 1, that function 2. So it comes to the function 2, void function 2, which means we have no return values. Okay, so void function 2. In the function 2, we declare again m equal to 10. Remember that previously we declare m equal to 1000. Now in this function, we declare m equal to 100. Then without any further, we call another function, which is function 1. We goes direct to function 1. So in the function 1, we define again, we initialize again the value of m, which is 10. Then we print the value of m. Yeah. So in this case, first printing process is in the function 1, where with the value of m is 10. So the value of m, when you print, the value is m. Now having done that, it goes to the function where it's being called, so which is here. Alright, so having done that function call 1, so those value m now gone. Okay, this prints m is the value of m in the current function, which is in function 2. So now the value of m now is 100, no more 10. As soon as function 1 exit, the process from the function 1 exit, the value of that local variable in function 1 will be replaced by whatever the value in it, if they have the same name. So the best way to avoid the confusion, just use different name. Much easier for you. Okay, and then having done that, we call 10 m equal to 100. Then we go back to the main function where we call the function 2. So here we print m. M now is not 10, not 100, but 1000, the value in the current function. So the output is 10, 100 and 1000. So basically that's what happened in the a local variable or automatic variable. Also, the way we declare the automatic variable, if you look at here, you can write as a auto int m equal to 10. It's just the same meaning, but it's of course more clear. You put it that way, then it means that this is auto or local variable. As well as here, you can put it auto m equal to 100. You can, just as an alternative declaration. The output will be the same. Okay, so the explanation given there is as I explained just now. You can do this. This is the way. So we may also use word auto as I pointed in the example. So a local variable lives throughout the whole program, although it's accessible only in the main. Okay, so the program with two subprogram, function 1, function 2, explain that example with m as automatic variable and is initialized to 10, 100 and 1000 in function 1, 2 and function 3, which function 3 in this case is our main. When executed, main call function 2, which in turn call function 1. When main is active, m equal to 100, but when function 2 is called, the main m is temporarily put on shelf, put aside temporarily, and the new local m equal to 100 becomes active. Similarly, when the function is called, both previous m equal to values of m, which is 100 and 1000, put on the shelf, and latest value m equal to 10 become active. As soon as it is done, the main, which is m equal to 1000, take over, and so on and so forth. Okay, so the process like that. Okay, so next we go to the external variable. Okay, external variable. So in this external variable, as I mentioned, we rarely use the external variable. Variables which are common to all functions and accessible by all functions of a programming are external variable or global variable. The external variable can be declared outside a function. There is of course the advantage of external variable. So we will look at this. Look at this example. So if you look at this example, so we have integer, sum, we have float, then we have main function here. Okay, main function here. So by doing this, so it means that sum and percentage are two external variable. Yeah, two external variables. So then the rest we can do whatever process you want to do. This is the main, and then function 1, and then function 2 if you want. Okay, so if you look at the notes down there, so we have the variable sum, and the variable sum and percentage are available for use in all three function main, function 1 and function 2. Yeah, so which means those variables sum and percentage can be used here, can be used here, can be used here. Okay, so however, local variable take precedence over global variable of the same name in the function where it is declared, which means if in the at the beginning we declare it as a external variable, so which means we declare outside the function main, and somehow in the main we have this function 1 and the function 2, and the function 1, for example, we still have the variable sum and percentage, we declare it here. So this declaration will override the previous declaration. So which means in this function, the variables sum and percentage, if you declare here, will be used according to the declaration made in function 1. Okay, I hope that clear. Look at this example. So we have integer I equal to 10, that is considered as a external variable. Alright, and then we have this example function with the argument 45. Alright, so we go to the example, the data. So this data, take the value 45. And then now we declare again integer I. So remember that I we have declared as a external variable with value 10. Now we have declared again as a local variable here, integer I. So data now 45. Yeah, data now 45. Now 45 here. So I means 45. When you print, the value of I is 45. Now when we go out of the example here, so prints I 45, I here is not this I equal to 10. It gives you I equal to 45. So we have both 45. Okay, I hope you can get that. So instead, if we put this integer I, put it here, we declare as a local variable, then we have the output will become 45 and 10. So that's the difference. Yeah, very obvious difference. So in the above example, the global variable and local variable have the same name as I. Look at the note down there. Okay. So local variable I take the precedence over the global variable. So take the precedence means if you declare I equal to 45 here in the call function, so the I take the value 45. Also the value that is stored in integer I is lost. Yeah, is lost as soon as the function exists. So which means the value of I equal to 10 as a global variable here, there's no more exist as soon as we call that function, because the process here we replace the value, we change the value of I and so on and so forth. Okay, so the global value can be used in any function. All the functions in the program can access the global variable and change it value, the subsequent function get a new value of the global variable. So when we call the function, the external variable, the value in the external variable, and as compared to the local variable, all right, so the local variable we use the current value in that current function. Okay, so it will be inconvenient to use variable as a global. So as you can see in the example, quite confusing. We want it, for example, we want the program print equal I equal to 10, but instead it's not print 10, it's print both I 45. So it's quite inconvenient. So it will be inconvenient to use a variable as a global because of this factor. Every function can change the value, as you can see that if you have another function, for example, and we have another variable names I, so here we change the value of I. In this function we change again the value of I, probably with different value, so it's difficult to get back to the I equal to 20, or otherwise we declare again, or we give the value again. So that's a multiple job for the same thing, right? Change the value of the variable on its own, and it will be difficult to get back to the original value of the variable if it is required. Okay, now next we go to the static variable. Yeah, what do we mean by static variable here? So the value given to variable declared by using word static. So we have the keyword here is static, persists until the end of the program. A static variable is initialized only once when the program is compiled. It is never initialized again. So if you look at the example, you look at this example here. You look at this example. So we have main integer void stat. So in this program we have the function name stat, and then we have a loop here. This part we haven't called the function yet. Now we have loop. How many loop we need? 4, right? 1 2 3 4. Then we call when j equal to 1, we call stat for the first time. So this function stat, inside there we have static integer x equal to 0. Remember that this static integer x equal to 0. So which means the value of x now is 0. And remember that as well, the value of x equal to 0 only declared as 1. Only x 0 only initialized once. What does it mean? Okay, look at further. So now x equal to x plus 1. This is for the first call. X equal to x plus 1. So the value of x now is 0. So which means the current value x equal to 0 plus 1 give you 1. So the value of x is 1. Now when you go out from that function, it comes to that loop, j now equal to 2. Then we call stat again. Now in the stat, in the function stat, you can see here we initialize x equal to 0. But this is not happen because it was static. Yeah, because it's a static variable. So the value of x is the previous value that we call in the first call. Alright, so which means x, the value of x is 1. So we have x 1 plus 1 is equal to 2. So when we print, the value of x equal to 2. So the same thing when for the third loops, we call that for the third time, we come here, the value of x is not 0 but 2, the previous value equal to 2. So 2 plus 1 become 3, and the process so on. So we have the output x equal to 1 2 3 and 4. Okay, now if we remove this word static, what will happen? What will happen? So you can see each time we call stat, for the first time we initialize x equal to 0, then x 0 plus 1 is 1, then x equal to 1, then come back to the 4, j equal to 2, we call that again. Remember that we don't have the word static here. Then we set again the value x equal to 0, then 0 plus 1 again give you x 1, and then for the third time also give you 1, for the fourth time also give you 1. So the output without this static, the output will become x equal to 1, x equal to 1, x equal to 1, x equal to 1, 4 times. So that's the difference between static and global and the local variable. Now for the register variable, what is a register variable? A variable is usually stored in the memory. Yeah. So this, which means that we stored in the memory the variable like a local variable, like a static variable, like a external variable, we store in the memory. Whereas for register variable, we store just in the compiler, so which means easy to access. It's fast, it's close to it, just in the compiler without going to the memory. Okay, how do we declare? How do we declare? Just that. So that's the way we declare the register integer count. Okay, so I think that's all. Let me read a little bit here. Since only a few variables can be placed in a register, it is important to carefully select the variable for this purpose. However, C will automatically convert register variable into normal variable once the limit is exceeded. So somehow the local variable used widely, and it's less confused, and it gives no error at all if you just use a local variable. Okay, so I think that's all for this video. I will stop here. In the next video, I will talk on the much more important when we deal with a big data. For example, how do we manage our file? So how do we read data from file and print or write to the file? So we will do that in the next video. Very important. So for now, I'll stop here. Remember that we have 4 types of variables, or 4 categories of variable, which is we have automatic or local variable, we have external or global variable, we have static variable, and we have last one is a registered variable. So that's all for now. Thank you very much. Bye.